part. Okay. So here you have some given functions, and they have relative extremum. All right. And here we're just looking at, even though this tells you, this here is considered critical and stationary, right? Critical and stationary because I can take the derivative, well, it's a horizontal tangent line. Derivative is equal to 0. Okay, so this is considered a relative max. Everybody okay? Here, critical point and stationary, yes or no? No, only critical. Okay, but this is considered a relative max because it's the highest y value on the graph. True? Now, could there be another high value for y somewhere else? This is just at the picture we're looking at. Okay. What about this one? I know it tells you, but does everyone understand this is a relative minimum? Okay, it's the lowest value on the graph. Stationary, no. Critical, yes. Questions? Okay. So, what do we do if we're looking for critical points and we're trying to determine if a function is increasing or decreasing? So we have what's called a first derivative test. Okay, and in order to be able to use a first derivative test, you need to know that f of x is continuous at the given critical point. So that's what they're telling us. Okay, and they're saying that if f prime of x is greater than 0 on an open interval from the left, okay, from the left, this is important, extending from the left, okay, and f prime of x is less than 0 on that open interval, extending to the right, then your function itself, not the derivative, but your function itself has a relative maximum at that point. And I'm going to show you. Okay, so here we have our number line for f prime. Okay, and we have our critical number x sub 0 on there. And what they're saying is, if you're extending from the left and you test in the first derivative and you get a positive value, see, f prime of x is greater than 0, meaning this is positive. What this means is that on this interval, f of x is doing what? Increasing. Yes, that is true. So if I were to sketch it, the graph is increasing. Everybody good so far? Okay. Then what the theorem says is that extending basically to the right from this value, f prime of x was less than 0. So what does that mean about f of x on this interval from x sub 0 to infinity? Decreasing. Goes down. So if your graph goes like this, up and then down, what's at the top? It's a max. Do you see how that works? Okay, so sometimes if you have to sketch it to see what's happening with the graph, okay, this is a relative maximum. But you have to look to see what's happening. It's not just saying, oh, f prime of x is greater than 0, boom, I have a maximum there. What you're looking at is what is happening from the interval before to the interval after. Everybody good? Okay. So then they're saying if f prime of x is less than 0, extending from the left, and then f prime of x is greater than 0 on that same interval, I should say 0, 0, okay? Extending to the right, I don't like where it says extending right, from that given value, then our function f has a relative minimum at x sub 0. Okay, so again, I would do the same thing, just to give you the example. So here's x sub 0. They're saying negative on this interval, coming from the left, positive on this interval. So if I were to sketch this, this means that from this, on this interval, up to x sub 0, my function f of x is decreasing and then increasing. So that would make sense that this would be a minimum, and remember, you're testing an f prime. Okay, questions on A and B before I move? Everybody okay? So then, if f prime of x has the same sign on the open interval, there's a typo here, extending from the left as it does on the right, meaning you have your number line like this. Okay, here's x sub 0, and let's say this goes positive, positive. Okay, you're increasing here, increasing here. You cannot determine if you have a relative max or relative min. Does everyone see that? Because this could be negative, negative too. Okay, and this should say then f has no relative extremum. Okay, because you have no idea what's happening. Okay, increasing, increasing, or decreasing, decreasing, but they're talking about at x sub 0. Okay, so this is a lot of rules, but let's see how it applies. So the first example says find all critical points of a given function, then determine whether these critical points are a relative max, relative min, or neither using the first derivative test. Okay, so there is more than one derivative test, and when you are given specific directions as to what to use, you're expected to use that test. This is actually the easier one. So if it doesn't tell you, use whatever you like. Okay, the easiest one. Okay, so the first thing we need to do is take the derivative. F prime of x is equal to 3x squared minus 6x. Okay, to find critical points, what do I do? Set f prime of x equal to 0. Can we factor at the same time?
Yes.
Yes. Okay, so let's take out a 3x, leaving us with x minus 2 is equal to 0. Okay. Critical points are critical numbers where x is equal to what and what?
3x.
Yes, 3x equals 0, so this would be 0 and 2. Okay, so I'm going to go right here. I'm going to draw a number line, slightly crooked, sorry about that. What am I testing in? F prime? F prime. Okay, I'm going to put 0 and 2. Okay, question, multiplicity, even or odd? Both of them are odd, so can we use a shortcut? What's a shortcut? Where do I start? Left or right? I start on the right. It's going to be positive, negative, positive. Let's do a quick test. Let's plug in 1. 3 times 1 is 3. 1 minus 2 is negative. Negative. We're good. Everybody okay? Okay. So what I was saying before is if we are looking from negative infinity to 0, f of x is doing what? Graphically? Increasing. Yep, increasing. So that means going up. And then from 0 to 2, f of x is decreasing. And then from 2 to infinity, increasing. So how could you describe 0? Relative max. What would make x equals 0 an inflection point? What does this have to be? F double prime. Okay, what is x equals 2? Relative min. Okay, nice. Okay, questions before we write our statement, which some of you are not going to like because it's a lot of words. Okay, this is to include justification. So, by the first derivative test, f has a relative max, see I'm abbreviating here, at x equals 0, bless you, because, why? F prime changes, this is where you have to be specific. F prime changes from what to what? Yep. From, and we can write it like this, positive to negative. Okay. That's your first part. Because in the directions it says relative max and relative min. So, I already wrote by the first derivative test. Do I have to write it again? No. Just keep going. F has what? A relative min at x equals 2 because f prime changes from negative to positive. Perfect. Okay. Is it possible that you might have to say f has a relative min at x equal, I'm making this up, x equals 2, comma, 4, comma, 7? Yeah, it just depends on your test. Okay, and I would just made up those numbers. Okay, questions on the first one? It was a nice, easy polynomial. Yes? Okay. Questions about how you write your answer? Okay. Let's look at the next one. Okay, we're going to have to write kind of small. So we have two options. We're looking to see where f of x has a potential relative min, relative max. We might not have any. We just have to see. Okay, so what do I have to do? F prime. Okay, I actually have choices. It's kind of amazing when you have choices. Some of us don't know what to do with ourselves when we have choices. I can use the product rule, or I can do something else. Suggestions? Distribute for sure, right? Okay, I might have to deal with some fractions, but I think I'd rather do that than make a mistake in the product rule, so I agree with you. Let's distribute first. So when we do this, this is 4x to the 3/5 power minus, when you multiply and your base is the same, what do you do to your exponents? You do have to add, so this is what? 5 over 5? This exponent is 5 over 5. So this is at 8/5? Okay, questions on how we got this? This is still f of x, which is why I have it written like this. We okay? All right, let's take the derivative. F prime of x is equal to 12/5 x to the negative 2/5